When we talk about the structure of the atom, we have the protons and the neutrons in the nucleus, and then surrounding that we have an area called the electron cloud that contains the electrons. The protons have a positive charge, and if we talked about their actual charge, we could do it in terms of a unit called coulombs, but it's a very tiny amount of charge in this unit of coulombs. So instead of that, we use a relative charge, and we say that the proton's charge is +1. And because an electron is the same amount of charge, but it's negative, we call that -1. Those are called relative charges instead of the actual charge. And so since neutrons are neutral, they have a 0 charge. Same thing for the masses of the three particles. We could use the exact mass, but you can see they're very, very tiny numbers. But we could take the number of each particle times their mass, add it up, and we get the mass of the whole atom. Or we could use a relative mass. So whatever a proton is, we're going to call that a relative mass of 1. And because if you look at the last part of these numbers, the neutron and proton are very similar in mass, we're going to call that a relative mass of 1 also. And then the electron is so much smaller, 4 more decimal places smaller, we're going to not really even include that in the mass. In some theories, electrons are not counted as matter, they're counted as energy, as waves. So we don't count the electrons in the mass of the whole atom because they're just so tiny. So if an atom had 13 protons, 14 neutrons, and 13 electrons, its mass would be determined by these two particles. Because electrons are so small, they almost don't even add any mass to the atom. And so we're going to put in 1 for each proton we have and 1 for each neutron because their relative mass is 1. And so our mass number would be 27. The atomic number is just the number of protons. So this atom has 13 protons, so its atomic number is 13. The protons determine the properties of the element. This element has certain properties because it has 13 protons. If it had 12 protons, it would act like a different element, have all the properties of a different element. So we could write for that last atom something called the isotope symbol. We would write the mass number, 27. We would write the atomic number, which is the number of protons again, 13. And then we would find number 13 on the periodic table, and that would be an atom of aluminum. Because it has 13 protons, atomic number is 13, it has all the properties of an atom of aluminum. So the mass number is the number of protons added to neutrons because they give the mass to the atom. The atomic number is just the number of protons. So if we had this symbol for sodium, the bottom number in our isotope symbol is an 11. So this sodium atom has 11 protons. The 11 protons result in all the properties that we think of as sodium. To find the number of neutrons, if you notice when you subtract these two numbers, the difference is neutrons. So if we subtract 23 from 11, we would get 12 neutrons. And because we want the pluses to match the minuses, if I have 11 positive protons in an atom should be neutral. I need to have 11 negative electrons. So in this atomic particles chart, you're given one number and you can find all the other numbers from that. So on the first line, we're going to do oxygen. This whole number is the atomic number, 8. On some chart periodic tables, it's on the top, some it's on the bottom. And then we're going to call this mass number 16, and we'll talk later about why there's a decimal there. So the isotope symbol for this atom would be 16 over 8, O. So the atomic number is that bottom number, that whole number, 8. Mass number is 16. Atomic number just means how many protons are there, so it's 8. If we want the atom to be neutral, the pluses have to match the minuses, so we would have to have 8 electrons. And to get neutrons, we subtract the mass minus the atomic, and then we also get 8. So for sulfur on the second line, the atomic number is 16. The mass number is, we're going to call it a whole number, 32. And in that first box, sometimes instead of writing an isotope symbol, we write the name of the element, and then we say dash 32. That means that the mass number for that particular atom is 32 protons and neutrons. They have the isotope symbol started, they have the 32 and the S, but you would want to put your 16 down here on the bottom, your atomic number. So the atomic number is 16, which means how many protons are there, and the protons, if 16 protons, you've got to have 16 negative electrons to make it all balance. The mass number is 32, and we get neutrons by subtracting the mass from the atomic number. So on the next line, all we're given is the atomic number is 30, so we know that it's an atom of zinc because if you look in the periodic table, element 30 is zinc, and so we're going to write the name zinc, dash, and then the mass number we're going to chop to 65, so zinc 65. To write the isotope symbol, we'll put Zn, 65 over 30. So we already have atomic number of 30, which means that there's 30 protons, and if you want 30 positive protons, you want 30 negative electrons. The mass number is 65, and so to get the number of neutrons, you just subtract those two, and you get 35. And on the fourth line, we have magnesium 24, so atomic number, mass number, chopped to a whole number. So our isotope symbol is 24 over 12 Mg. So we have 12 per atomic number, which means there's 12 protons that make up the atom and give it its properties. If there's 12 positive protons, there are 12 negative electrons. Mass is 24, and neutrons is where you subtract mass minus atomic number. The last four columns in the chart are to show where the total electrons are placed. We have the protons and neutrons down in the center in the nucleus, and then we have these rings around the nucleus. They represent orbits around the nucleus, and they can hold a certain number of electrons. And so the first level is fairly small circumference, so only 2 electrons would orbit at that distance. The next ring is a little bigger, so you can have 8 electrons in that ring. The next one is 18, and the last one is 32. So to complete the last 4 columns, we're going to use the total number of electrons, and we're going to place electrons at each of the levels until we run out. And the rule is you have to start on the first energy level closest to the nucleus. So of the 8 electrons in oxygen, the first 2 are going to go on the first level, and that leaves us 6 more to go on the second level. So the outer edge of the oxygen atom is 2 levels away from the nucleus. There is no third and fourth level for oxygen. For sulfur, 16 electrons, 2 go on the first level, 8 in the second, which leaves us with 6 electrons in the third level. So there is no fourth level for sulfur. The sulfur is a larger atom than oxygen because it extends 1 more energy level. For zinc, there are 30 electrons total, so 2 in the first level, 8 in the second, 18 in the third, that's 28, which would leave 2 electrons in the fourth. So zinc has 4 energy levels, has electrons that extend 4 levels away from the nucleus. And magnesium has 12 electrons, so 2 in the first, 8 in the second, 2 in the third.